Okay, I know this sounds preposterous, even crazy, but hear me out for a second. What if quantum mechanics, which is the science of the tiniest particles in the universe, could teach us something really important? Something about how we think about people, society, and even economics. All right, stick with me because this connection is way more practical than it first seems at the first glance. So let's start from the basics. What is quantum mechanics? It's really a branch of physics that deals with super tiny particles. And it has this wild idea called the wave function, which I want to go over here. What is the wave function? Well, it is really using mathematics to explain and describe the probability of a position of these little tiny particles that are measured and studied in quantum mechanics. Basically, physicists, due to hard barriers in the knowledge of where an electron is in terms of its location as well as its momentum, they describe their location by a wave function, which is really a probability map of where this particle might be because we just don't have that information at hand. But what's interesting is once someone goes in there and measures and finds the exact particle that they're looking for, then all of a sudden the wave function to represent the probability where it might be collapses into a flat line as the information about the whereabouts of this particle becomes clear. Essentially, uncertainty through information leads to certainty. So remember what I said in my information series, that information is the process of reducing uncertainty. Schrödinger, for example, used the cat in a hypothetical box analogy in order to explain this wave function as an analogy, but I'm going to use an easier one. Imagine, for example, that you have a friend named Joe who works super hard. In fact, Joe works so hard that at any point during the day, he's either at work or at home. Now it's around 6 o'clock and you look at your watch and you don't know where Joe is. So mathematically speaking, the wave function representing his potential whereabouts includes him still at work, already at home, or somewhere in the middle. And that's the uncertainty that you have to deal with in that wave function. It's the probability of where he could be. But you decide all of a sudden to drive to his home, and when you ring the bell and he opens the door, suddenly you're facing new information about his exact location, which is home. So the certainty of Joe's exact location causes the wave function of his potential whereabouts all of a sudden to collapse into a point of certainty. You have figured out at that moment of realization that he is at home. Now, a similar thing happens when physicists locate a particle by measuring it. Boom, the wave function of its potential whereabouts all of a sudden collapses, and we move from uncertainty to certainty through this measurement and gained information. Information causes the wave function to collapse. All right, so keep that in mind as a conceptual framework, because you're probably wondering, what is the relationship here? So let's talk about, for example, the psychological and sociological things that we all do in a society, and those are called generalizations. You know, those big assumptions that we all make when we make broad statements about social groups and demographics, such as like men are stronger than women or millennials are bad with money. We oftentimes talk about these generalizations, and each individual in this probabilistic curve would be very different than our average generalization that we use for the group. So in some ways, generalizations are just wave functions. They're not about specific individuals. They're just about the probabilities and trends across a whole group. It's like drawing a big bell-shaped curve that says so-and-so is probably the case. But here's the important part. Just like in quantum mechanics, generalizations aren't reality. They're just a potential model for the truth. The moment you deal with a specific person, that generalization collapses. You're no longer talking about probabilities. You're now talking about that person. Furthermore, some generalizations are not based on any kind of study. They're just mere perceptions, or they're anecdotal. And that's really where things get tricky. The information about any given individual may not necessarily conform with our generalizations for the whole group. And that is the problem. Why does it matter? Well, this connects to so many parts of our lives. Let's take identity politics, for example. It thrives in grouping people by race, gender, or other traits. These groupings can be useful in understanding big trends, but they also risk turning individuals into stereotypes. When we see people only through the lens of their group, it's like facing a wave function to collapse in a way that flattens all of their complexity and individuality. Instead of seeing the whole person, we just see them as a representative of a category. As a result, identity politics tends to promote stereotyping and also generalizations instead of helping to eliminate them, which has really been the goal for the past 100 years. The same thing happens in economics. When economists create policies based on group averages, they're really working with probabilities, like a wave function. But those averages don't capture the messy reality of individual life. And what is the result? Well, policies that might work for some people in the group, but leaves out those who don't fit that specific stereotype. So what is the big takeaway here? The deal is that generalizations aren't necessarily bad. They help us, make sense of a complex world when we have to make decisions without all of the necessary information at hand. But they're not really the truth either. They're just tools. In quantum mechanics, scientists know the wave function isn't the whole story. It's just the way to guesstimate outcomes, not to predict them with complete certainty. So what we need is also to bring some of that same humility to how we use generalizations in the society. They're helpful, but they're not the final word. So whether we're talking about quantum particles, social categories, economic data, or even political decisions, the lesson is the same. Don't mistake the map for the territory. Trends and statistics are useful, but people are complex, and reality is always richer than models that we use to describe it. So what do you guys think? Is this a useful way to understand the problem of generalizations, or is it making it more complex? Of course, by adding quantum mechanics to it, I'm not sure we need that to arrive at this conclusion. But this type of microcosms are the kinds of things I'm interested in, and I'd like to bring to this channel in future videos of connecting these concepts at the micro level to the macro level. So let me know if there are any specific areas of interest that you want me to get into on this channel as well. I'd be willing to look into that. But thanks again so much for tuning in, and stay curious, question everything, and I'll catch you guys in the next video.